right, we're getting started. So let's watch the counter for a bit. Let's watch the counter because there should be more. There should be more GPUs coming in here in a second. So I kind of want to see it. Kind of want to show it live. But we're gonna be getting started here in a second. I mean, it should happen any minute now. Any minute now, we should get the counter to increment. So I'm gonna leave it in the background. So bunch of stuff going on. So today we're gonna be playing around with basically, I mean, I've been talking about it for a long time. So I'll go. Oh, there we go. We got it on video. I saw there was machines connecting, so I had to show it to you guys. We just got more GPUs. All right, now I'm ready to go full screen. Watch this. Oh crap, I forgot. I gotta hit 2 buttons. So all right, we're in guys. So let's have a quick discussion about a couple things that's going on our end. So first things first, we are gonna be playing around with some epic models today. So I got a lot of feedback that people want to see what happens in this behind the scenes, because I mean I'll explain the conversation that I was having. So I was like, talking to somebody, and then I'm explaining like what I'm doing, and then the person said, well, why don't you show that on stream? And I was like, well, why would I give away like how we build this stuff? And then the person made the point like, how many people who actually follow you guys have H200s? And I was like, all right, fair point. So I mean, the thing is, like, a lot of this is knowing how to package it, knowing how to get it up and running, knowing how to get the drivers installed. So there's a lot of I mean, it's basically, I don't want to like, don't get me wrong, there's like a lot that goes that happens behind the scenes. Like it's really a lot of stuff, but at the end of the day, it's a lot of DevOps to get these machines up and running. So like, don't be surprised if you think that some of this you've seen, you know, elsewhere that we'll see today. So for example, we're going to be running Llama CPP and stuff like that. So I mean, like, if you guys think we don't utilize all these open source tools, and I mean, that's the entire point. Like, so much of this is open source, has open audited code bases. I mean, we're standing on the shoulders of giants, and basically all that stuff is freely available to us. So let's get started. So real quick, I do want to drop one thing. I do want to drop one thing in the chat. I do want to drop one thing in the chat, which is, I want to drop it in our Telegram chat, because somebody complained that we didn't stream in a way that was Telegram friendly last time. So I actually spent the time to set it up on YouTube. So streaming is on YouTube. I don't know if you guys want to watch it on YouTube. It's slightly higher quality then. I think it's 1440p. So you'll see dimples on my face even more, or something like that. I mean, imagine, I'll let your mind wander as to which videos are impacted the most by the higher quality. So we'll check that out. I do want to so I'm gonna I'll actually send that out if you guys want to see it. So let's do it really quickly. I'm just gonna do, I'm doing a couple housekeeping things, guys. You can't, you know, it's a live stream. It's like we gotta make sure people connected. We gotta make sure people are asking questions in the chat and all that kind of stuff. And then we'll get it up and running. I mean, yeah, let's see if I can get this to load right now. Anyway, let me drop the link in Telegram. They'll be the most excited. So here, actually, I got both going right now. So I'm gonna do so here, I'm gonna do this, and I'm gonna paste it in our Telegram chat just in case somebody wants it there. Let's paste it over there as well, and then we can get started. Should all be good. So I think we got everything up and running. So so yeah, so all right, now I feel better about it. All right, I'm gonna kill Telegram. So questions, I mean, if you guys are in the Discord I have open, so I'll be fast to respond there. I'll try to read any questions that we get on the stream at the end of the stream on X, but like, don't twist my arm. I'll do my best, but I can't promise it. And then in terms of if you guys want, I mean, yeah, in general, ping us in the Discord is the best place to get in touch with us, etc. So I'm gonna show you guys a little bit how the sausage is made today. So there's gonna be some stuff, like some internal stuff, let's say. So I'm gonna show you guys how we, like, the kinds of development machines that we run and all that kind of stuff. So I'm gonna show you a little bit, like, sneak peek of what's going on there, etc. I do want to get a couple things up and running before we do that, and so, but I'll pull them in here in a second. But so let's have a conversation about all the stuff. So like, bunch of stuff, guys. I want to, for those who missed, I mean, we came back after a hiatus last week. So we're still adding the stuff that we did last week to the front end, essentially the Unireg stuff. It works. We tested it on stream. It's got to get built and packaged, and then you guys will be able to launch them really fast. Trying to think what else is super important, worth mentioning. we got a so I mean, other than that, I'm trying to think what else is super important. I mean, we've been playing around a lot with model training, so I've been talking about that a lot. So if you're a project, I mean, here's like the PSA, the public service announcement for this week, because I think it'll be something that we talk about next week, so look forward to that. Is we're collaborating with a bunch of projects. So if you are a project, you want to do something AI related, and you want to train your own model at like the lowest possible price, and we'll be like fully transparent with our input and output costs and all that kind of stuff, and you want to essentially involve your community, have your community be able to sponsor you and work with you, and essentially pay for the hosting costs, etc., make sure to get in touch with us. Get in touch with us via DM, etc. Those are the kinds of projects we're looking for right now, and those are the kinds of projects that we're working on. So we have the infrastructure for it. It's up and running. I mean, we've been doing it in essentially a test mode internally, and I'm looking forward to showing you guys what it's going to look like when it's actually up and running. I am tempted really quickly to fix one thing, which is, all right, let me do this right here. Got to get a more orangey color on the camera. It was too yellow last time, so I fixed that in the background. Other than that, the big news, or kind of the reason that I think most people are going to be here today, is so I've been saying this for a long time. So come in, children, come in. Let me tell you a story. So people always ask me about because I mean, you know, whatever, full time, what are we doing? We're playing around with different models. We're playing around with video generation models, audio, all kinds of models. We're playing around with them. So what happens with I mean, we go and we test a lot of models. So there's some models that are just like clear winners, like Hermes 3, shout out Noose Research. I mean, are just super useful, work significantly better than something like a llama or something like that, and they just have their place. But then there's a ton of new models that come out. So people forget that there's more and more models coming out every day. More and more, not fewer, more and more. So just because you're on crypto Twitter, on AI Twitter, and everyone's talking about Grok, that's not the only model that's coming out, guys. It's not the only model that's coming out. So moreover, the thing where, like, personally, if you're asking me for my personal, you know, professional expert opinion, I think the most interesting thing that you're going to see with open source models, and where there is a very high likelihood that they're going to win, is that you're going to have open source models that are superior to the generic OpenAI, ChatGPT, Grok, Super Grok, Anthropic, Claude, whatever. These generic models that are frontier models that try to cover all bases, they're going to be pretty good at covering all bases, but they're not going to be as good as certain models that are absolutely like laser focused on a specific thing or two. They're going to be like, you know, there's going to be models that work for specific stuff, and they're just going to be better. And so, for example, if you have a project, let's say you have a project where you're running AI agents, and you can generate synthetic data, training data about essentially the types of interactions that this AI agent is going to have. And then you train either a model, or you do some sort of essentially retrieval augmented generation, so a RAG. So you essentially give it a bunch of context that's specific to the task that it's solving. You're going to get a better result than if you just connect this, even you know, whatever, Claude 4 Opus to whatever the latest OpenAI thing is, to Super Grok. You're going to get a better response, because there's no chance that Super Grok has the training data that you have. And so there's always going to be a niche for super specific stuff trained for like what you are trying to achieve with that model. So that is the niche. And so one of the best examples with, so I mean, like without, so like I'll give you, I mean, the perfect example, like we're going to be making a segue to coding models. So how do people train coding models? So first of all, so I mean, I'll this is like story time with Dimitri. I'll give you guys a short story. So when I like before vibe coding had a name, I was already vibe coding, right? So the first test that I did, because I'm a security engineer, I audit people's code. So we tested, I tested what I was doing. It was I was testing the code quality because I can assess the code quality of JavaScript, TypeScript, of Python, of C. And so I tested all this stuff, and I mean, I can tell you, like mid 2024, right when the coding models were really becoming more and more of a thing, it was already very clear. I mean, I'm telling you, hand on heart, whatever you want to call it. I'm telling you, I did this test. The Python code was way better than the Go code, than the JavaScript code. I mean, it was like, decent code. And so from my point of view, as many tests as I do, that's still true. Okay, so the Python code that you get out of a coding model is still the best quality code that you can expect. So my hypothesis is, which I'm pretty sure about, is what's happening is all of these frontier labs, since they are working with NVIDIA CUDA, since they're working with PyTorch and all this kind of stuff, they actually have a ton of Python code. So what do they train the LLM on? They feed the freaking code that they use internally into these LLMs. So there's a disproportional amount of venture-backed, highly funded, well-written Python code that gets injected into these models, which is why the Python, I mean, so basically, they probably train it on the entire PyTorch branch, on NVIDIA CUDA, I mean, all the Python bindings, all that kind of stuff. So the Python code objectively is better than a lot of other code that you get, and especially if it's like a new language, a poorly documented language. I mean, what you're doing the entire time is you're pasting freaking documentation to be able to write that. So I mention it because I actually have I'm not gonna say a name. I have a friend of mine who actually suggests doing like if you have a specific style and stuff like that. He actually trains a LoRa, which is basically like a fine tune, so like a adjustment to the model based on his code, so that the model actually produce code that looks like his code. I don't bother, to be completely honest. I mean, for me, that's too big of a time investment, but it's totally a valid approach. Like fist bump to him for doing that. I think that's an interesting way to approach it, and like that's the thing. So I mention it because like where do the coding models get all the stuff? I mean, so like the perfect example is like what GitHub Copilot is what's GitHub Copilot? I mean, GitHub Copilot's like $20 a month or whatever. You're the product, guys. You're the product. I mean, if you read the freaking documents, I mean, it very clearly says that your code can be used for additional training for models. I mean, same with Anthropic, to be honest. I mean, with all these things, I mean, they say that they're gonna that they reserve the right in certain situations to like anonymize your data and then use it internally. I mean, are they going to anonymize code? Are they going to change all the variable names? If you have like log in to secret government server, are they going to change it to not log in to secret government? I mean, so like I'm just telling you, it's a gigantic problem. The fact that there's like a gigantic incentive for all these companies to essentially swallow up all of the code that you have and to train them internally for their use cases. So the reason I mean, like, just keep that in mind. So the cool thing is, I mean, or sort of cool thing is, you have companies like, for example, Google, or I mean, just to like sort of segue into the stuff that we'll be doing today, you have companies like Alibaba, which is, I mean, basically China's biggest internet company. I guess they're closer to Amazon technically than Google, but you get the idea. I mean, they're a cloud provider, all this kind of stuff. They also have a ton of code. Guess what their model gets trained on? Their model, most likely, I mean, I'm telling you, they don't have to license it. They can take their proprietary code, train their model on writing their code, and then this model produces decent code, which is roughly what it was trained on, which is probably their production code. So I mention it because what if you're, let's say, I mean, Anthropic or something like this? What do you train? What code do you use? Or like, let's just assume. I don't mean to like name a name. I mean, it's just like it doesn't matter. You can insert any name here, but let's just say Anthropic Claude, just for the purposes of this discussion. Not saying the caveat here being that this doesn't necessarily have to be true, but you guys get the idea. What I mean by Anthropic is not Microsoft. They're not Google. I mean, so they don't have a gigantic code base that they can use because, I mean, obviously, Microsoft has Office 365, has Azure, has all these companies. So they have a ton of code bases that they can actually feed into any coding models that they try to produce. What would a company that doesn't have that do? And this will, again, segue nicely into what we're discussing today. So what do they have to do? One of the things that they can do is they can go grab the Linux kernel. They can grab all the open source Linux utilities. They can grab all, I mean, fortunately, most of Python is open source. They can basically go through PyPy and grab everything there. They can go through NPM and grab everything there. And so that's what you can expect. I mean, that's what they're being trained on. So what's like, if we're to guess, what's the temperature of the room of like NPM? I mean, like what would I expect? Is is like the Google code quality better than so here's like a perfect example. So even with compute AI, we have a couple, I mean, so in case you didn't know this, Go is written by Google. So I vow, like 100%, you can quote me on this. I did a quick like coding test of Go code produced by Claude and Go code produced by Gemini Pro. And guess which one won? Guess which one won? It was Gemini. It was freaking Gemini. So I do use, so for example, if we're changing part of our backend that has to get written in Go, which model do I choose? I choose Gemini. Why is that? Because I know Google wrote Go. Google has a bunch of Go projects for a bunch of the production stack that Google runs. And so where do they get this code from? It's their production code. They just stick it into the model trains on it, et cetera, et cetera. So all these companies do it. So in a way, I mean, even though Anthropic's like the leading coding model, you could argue they're at a disadvantage because they don't have a gigantic legacy code base, or they don't have a family of gigantic legacy code bases like a search engine or something like that they can stick into this thing and train it. So they're sort of at a disadvantage in terms of having the license to be able to freely train a model on a gigantic code base to be able to produce code. So I just mentioned that because today we're going to be talking about the open source models, and there's two options. So there's Qwen, which is written by Alibaba Group, and then there's Kimi, which is written by Moonshot AI. And Kimi is, I mean, as far as I know, I don't think Kimi is part of a gigantic internet company. So they're at a slight disadvantage in terms of the code because Alibaba has the Alibaba store, their subsidiaries AliExpress. They have all this code there. They also have Alibaba Cloud, so they have all this infrastructure code from running their cloud services, et cetera, et cetera. So I mention it because we're still so early on our AI journey that all this stuff matters. Like the data sets that get the data sets for coding that get put into these models make a gigantic difference. And so my expectation, I mean, I'm like going to be completely like frank about it. My expectation is even though like my DMs were blowing up with everyone telling me how much that they don't believe in Qwen. My personal expectation is that when we run Kimi versus Qwen is going to be Kimi, just because it's not the first time around for Qwen, and Qwen just came out and it comes from Alibaba Group. So I expect them to just have better sources that they can stick into this thing. So I mean, that's my assumption. We'll see. So next thing I'll say is I tested the models. I mean, what Kimi's running right now, I'll show you guys. So the way that here, I'll give you guys like a couple of housekeeping things. So how are we going to do it? So I'm going to show you. So Kimi, I got up and running. Qwen, we're going to get up and running together. I'll show you guys sort of the steps and the frustration and like, I'll like, it'll be interesting, right? It'll be good video content for people to watch if you want to see what Dimitri and every AI engineer across the world that's trying to essentially build this at scale, the kind of stuff that they're doing every day, we'll show you. We don't mind. We'll show you. But it's going to be a lot of downloading. I mean, I'm not, I mean, you know, it's going to be a lot of downloading. I mean, fortunately we have 25 gigabit down, or like 100 gigabit down, something like that. But I mean, it's going to be a lot of downloading. I mean, if you don't try this at home, basically. I mean, you don't want to download a terabyte of models. I mean, I can do it because I got, you know, 2500 gigabit down on the server that I'm going to be on. But if you did this at home, I mean, make sure nobody's watching Netflix, basically. I mean, you're not going to want to do this at home. So it's going to be a lot of downloading, and you're going to need 8 H200s, which are, I mean, so we're just going to need, you know, I mean, we have 2 models, so we're going to probably need 2 machines. Each of those machines, each of the GPUs is going to be $65,000. So times 8, so that roughly comes out to $500,000. So we're just going to run $1 million worth of servers today, just to be able to run this. I mean, maybe you can run it at home. I don't know what kind of power you get from the power company or anything like that. I mean, it's up to you. I mean, if you can do it, you can do it. So but I mean, obviously we're running in a data center and stuff like this, and it's all gonna be great. And so I'll give you guys, I mean, so what I'm doing in the background without you seeing it is I'm just booting up. I already booted them. They've been running for like, you know, 2 hours or whatever since I've been playing around with them. But I booted up a couple test machines. They don't really have anything on them except they I mean, they run essentially the compute AI like scripts that install all the NVIDIA drivers and all that kind of stuff. And so they're fully set up so we can just log into them and start playing around and start running. So like Docker is set up so we can run containers and do all that kind of stuff. And it should all be good to go. And then I mean, so the way that we're going to do it is I'm going to get these up and running. We're going to get them up and running. I'm going to, and it's going to be so that it's slightly annoying for everyone watching, so that you have to join our Discord. So I'll show you really quickly where you can join our Discord. I'll show you guys really quickly, just so that you see it. So I'm going to pull it up right here, and I'll show you guys. So, all right, wait a second. Oh, I'll pull it up. See. All right, perfect. We got, so let me show you guys it really quickly. So it was just being slow. So let's do this. So really quickly, here's our website. I mean, the website that we have right now. Oh man, OBS is slightly on this screen. So this is the website we have right now. Right here, you guys can see our X, our Telegram, our Discord. I mean, make sure to join all our socials, subscribe to our YouTube, all that kind of stuff, our GitHub, etc., etc. But basically, Discord's right here. So if you guys click that, you can join our Discord. And what's going to happen is after today's stream, I'm going to post URLs there so that you can use if you guys want to play around with them. We're going to leave the servers up and running probably until Saturday. So it's going to be really like, I'll say it on the stream. They're not going to have authentication or anything like that on them. We're just going to leave them up and running. I'm not worried about it. There's going to be HTTPS running on them, but like no authentication and stuff like that. So you don't have to worry about somebody like sniffing the queries that you send there. But I'm not going to do the authentication right now. Next week, after we decide which of these models we like more, next week we can actually try to integrate them next week we can actually go and try to integrate them into our API. And once we've decided who the winner is, basically. So that's going to be the plan on that one. So I'm trying to think what else. So let's see if there's anything else worth mentioning. So basically, I mean, the goal here with this exercise, or like playing around with this, so for the longest time, so actually let's pull up let's launch a GPU. Let's do it together. Let's try it out right now. See how fast it loads. No, it's fine. I think it's gonna be fine. I'm having Firefox is acting slow. I gotta at least from the stream, I should have pre-rendered this. It's just my DNS. Something's wrong with the DNS. It's just super slow to resolve. So what I just want to show you guys that if I log in, it'll load way faster for you. This a Dimitri stream problem with how I'm streaming right now. All right, let's go back to full screen. I'll wait for it to. No, there I just do it and then it loads right away. So you're not gonna have this problem. All right, for now I gotta go back because I'm not showing you guys my password length essentially. But you guys will be able to so let's go back. So basically, I mean, yeah, it's slow, guys. For me, it won't be slow for you. So you guys will be able to use the API key and you should be able to access it. So we'll publish all the stuff in our documentation. And the thing is, up until now, for people trying to do coding stuff, we've been running these coder models. So let's just launch one just so that I can show you guys really quickly. So let's boot one up. Let's see. Hopefully it doesn't take too long. I should have tested this before. No, and I'll have to see if it's I think that's let's just try it again. It shouldn't be, you should be able to boot one. Yeah, we should be able to boot one right now. It shouldn't be an issue. It's my internet, guys, unfortunately, with the stream, with the way that I decided to do the stream today. I'm not changing my internet settings just to like have a smoother internet connection once we're live, but trust me, this won't happen on your end. It's purely a Dimitri problem. But basically, I mentioned this to say we actually have a container. So this is gonna run on a GPU. Let's check what GPU we're running on right now. Yeah, it's a L. So in this case, it's not an H200 right now. It's gonna be an L40S, and it's actually running all of these models. So you guys can actually check out. So once we connect to the UI, so here it comes. It's gonna load a little bit, but one of these instances is actually gonna have a bunch of models on it, and so that's gonna load here in a second. So we should be able to get in and see what models are in there. I'll give you guys a quick overview. So up until now, so let me explain it one more time, like what I'm talking about. So up until now, how have people been using coding models on our thing? They've essentially, gone to launch. So this interface, they've launched a node. So they've launched essentially a GPU instance on our network. And then they connected to that instance and then did all the things that they wanted to do. Man, I've got to next time I'm not setting up the internet like this. I thought it would be better because I would have I have a faster upload, so I can with like tunneling like this, but it's making the pages load so slowly. So I mean, it should load here in a second, but it's just me. You guys won't have this issue. But basically, we're running on these instances. We actually run something like 10 or more different coding models. And so up until now, that's what people were essentially using with our with our stuff. So now it should be fast, like it's a DNS problem, guys. So we actually run all of these coding models. So we got Granite Code, we got QWQ, which isn't really a coding model, but it does have essentially a coding expert built in. Code Llama, Qwen Coder. So the previous Qwen Coder is on here. Then we have DeepSeek Coder, et cetera, et cetera. So the reason that I mention it, let's see if I can make it bigly. Let's make it bigly just to show you guys. How many parameters do these guys have? We have like 33, so basically 34 billion, 32 billion, 34 billion, 32 billion, 16 billion, 7 billion. So roughly, not like, don't quote me on this, I know what the difference is, but roughly multiply that. Whatever the billion is, it ends up being a gigabyte. Roughly, because it translates, like the 8 translates into gigabytes used. It's literally like, billion is giga. So it's a rough, it's not super accurate, but essentially if you have a 7 billion model, it's going to be like 7 gigs of video memory that you need. If you have let's just run Qwen Coder and then let's tell it, let's go down here. I made it too big, so let's change the font. Let's go back and say show me a code snippet. Perfect. Let's go do it. So over here, we should see the GPU and the VRAM getting loaded up here in a second as it begins to load this model. So we'll see it here in a second. But basically, there you go. GPU 98%, VRAM 71%. So this model is roughly, we have a 48 gig memory GPU, and this model is going to take up, actually going to take up like 77% of the memory. So it's basically, so you saw it's a 32 gig or 32 billion parameters, and it's roughly 34 gigs of VRAM that ends up taking up. So I'm trying to make it bigger, but the font's not getting that much bigger, I think. But it's basically taking up 34 out of 48 gigs. And so, I mean, with all the giga, I mean, so we have a 48 gig card, it's like 45, and then it's, I mean, so all the math's slightly off, but roughly you get the idea. So how big is Kimi K2? And so basically, how much VRAM do you need to run Kimi K2? The default Kimi K2. So there's, I mean, I'm not gonna go so much into, I mean, we'll talk about it a little bit, but I don't want to go into it yet. But the answer is you need 2 terabytes. With Kimi K2, you need 2 terabytes of VRAM. So what is 2 terabytes of VRAM? That is 2 H200 servers. So that's $1 million worth of hardware you need to run this one model. So fortunately, and I'll go full screen just to make sure that I can pull it up really quickly. Fortunately, our friends at here, right, let's try it. Our friends over at so let me see if it loads. Yeah, I screwed myself with this tunnel. I mean, I built the tunnel so that I would have more bandwidth to stream with, and now the downstream is like crippled. The downstream slow, so like the website's loading for me is slow, but the internet traffic going out is significantly faster. So I need a better solution for next time. I'll look for something there. But basically what ended up happening is there are our friends, not literal friends, but we're big fans of their work. There's essentially a company project called Unsloth AI, and what they're doing is they're taking these models and they're fine-tuning them to be more reasonable in terms of size. So Qwen Coder 3 is a 480 billion with a B parameter model. And so that means it's going to take roughly, I mean, so basically it's going to take like half a terabyte of memory at Q8, right? At BF, if you use the 16-bit floating point, it's going to take a terabyte. So essentially the uncompressed one's going to take a terabyte. So this is the one model that we're going to run. The other one that we're going to run is going to be, where is it? Kimi. They got a Kimi. Where's Kimi? Kimi, where are you? So here they got Kimi K2. So Kimi K2 is a 1 terabyte model. So that means we need so basically, I mean, so when the math that we just did with the parameters equaling how much RAM you need, how much video RAM you need, that works for Quant 8. So technically the uncompressed default model is not Quant 8, it is floating point 16. So you have to do whatever that number is, you need times 2. So essentially what that means is if you want to run the OG just the release Kimi, you need 2 terabytes of RAM. So 2 terabytes of RAM means you're running 2 H200 servers, or you're running 4 H100 servers, which is a lot, guys. It's a lot to be running. I mean, I don't think you're running. I mean, I should show you guys on there was a recent I'm trying to remember where he went, but there was a recent Serve the Home, which is pretty good, like DevOps nerd YouTube channel. He went to a data center, and then like there's I can't remember, it's like either 4 or 8 of these machines in a rack. I think it's 4. So literally we would be an entire rack going to the ceiling. That's how much space it takes to run one of these models. It's like, I mean, it's like $1 million worth of hardware, and like hundreds, or I mean literally like a kilowatt or something like that. I mean, not 1 kilowatt, but like 8 kilowatts or something like that of electricity. I mean, it's just absolutely insane, the size of these models to get them up and running. Fortunately, I mean, I'm still going to show it. Like, that's not to say I'm not going to show you how to run it. That's exactly what we'll be doing today. But it's like all this stuff is completely unobtainium for running at home. So the cool thing that Unsloth does is you basically have, so the way that it works is, I mean, I was thinking about how to explain it, and I was thinking of our Vorlesung and Informatik in Germany that we had, and basically, I mean, the way to think about it is the quantization is basically how accurate you are in quantizing something. So basically, what that means is how many steps do you have, and so if you have like, let's say you have 8 steps, so like up here, up here, up here, up here, up here, up here. So now if you have a number anywhere between them, you'll have a better precision. Whereas, so if you have 8 steps, that's like a quant 3. So if you just have 4 steps, that's like a quant 2. So you won't have, there's going to be a difference from like the value that you're trying to get and where the actual step is, like where you round it to. And that's going to be a quantization error. And so that's exactly what's happening, even though, I mean, like technically it's floating point, but that's exactly what's happening when you're talking about, quantization and quantization errors, is that the higher the quantization, the better you're gonna like curve fit the data that you're trying to get. And with lower quantization, you're gonna have like a bit more error that accumulates over time, and you'll get worse results. So from a practical point of view, quant 8 and the full floating point 16, it's not gonna make a huge difference. Moreover, I had this question from a very smart person, but was asking what's the impact on like the processing performance, and the impact on the processing performance should, like, knock on wood, in the best case scenario, it should be 0, because all that's happening is you're loading numbers into essentially hardware registers. The NVIDIA GPU is doing all the matrix multiplication and is doing all the floating point multiplication in hardware. And so it's not going to make a difference what the quantization is. So you shouldn't have, I mean, ideally there should, if it's happening in hardware, there shouldn't be a difference between floating point 16 versus floating point 8 versus floating point 4. There might be, in terms of like the carry logic and stuff like that, I mean, there might be a little bit of a hardware impact, but it's not going to be a gigantic hardware impact. Literally what you're saving is you're saying, I accept that I'm going to have some errors for the fact that I can fit this in a memory. And so I mention it because Unsloth, being the ballers that they are, they'll actually give you other models. So they have like a Quant 1, which, like, I mean, do not try to run production code with this, but I think these smaller models and the way that this works, so at least Kimi being what's called a MOE, so a mix of experts, so it's essentially an expert like on a, I mean, it like activates different parts of the neural network depending on what it's trying to do. And so there's, for example, a coding expert within Kimi. So they basically say that you can run like 1 or 2 bit, or the 1.5 bit model. You can run on like a 30, 40, 50, 90. I didn't even bother. Guys, we have H200s. I mean, what am I supposed to do? Am I supposed to cripple myself just for, I mean, what am I, plebe? Am I plebe? I can't, I'm going to run on the gigantic thing if I have access to the gigantic thing. So I haven't tried these locally, but just for those following along at home, hypothetically, you could try to run one of these locally. Have not done it. I've only run the full-blown thing. So I'm going to show you running the full-blown thing. So technically, so one more caveat here. So I'm going to get all these caveats out of the way. Technically, we're not running the full-blown thing because the full-blown thing takes 2 terabytes of memory, and that will not fit on a single H200 GPU. We're running the Q8, which does fit onto a single H200 server, and it still has a little bit of room for cache and everything like that. So this is technically the model that we're running. But if I mean, just like the tests between like a full FP16 model and a Q8 model, they're not that big. I mean, you'll see, I mean, usually it's like less than 10% worse responses. I mean, so you like, and I think it's even less than 5% in a lot of cases. So essentially you're not losing anything by going to the Q8. After you go from the Q8 to like the Q6, Q4 and all that kind of stuff, then you're losing. I mean, you're gonna be able to tell the difference, but generally with Q8 you won't be able to tell the difference. Fun fact, I'll go full screen. Fun fact, Ollama by default, if you just go and download models, Ollama always downloads a Q4, which is not great because most of the time, if you have like a 50, 40, 90, 30, 90, and you have 24 gigs of RAM, you probably want to take like a 7 billion or 16 billion parameter or like 14 billion parameter model, and then either do FP16 or Q8. I mean, that's going to fit into memory. So Ollama unfortunately defaults to Q4 because that covers a wider range of consumer graphics cards, but that's not optimal. I mean, so this kind of stuff appears on when you run Ollama as well. So I mean, you can actually see that. I'll show. I'll start loading olama.com in the background, and then I'll show you guys. But you can actually see you can see the quantizations that are available and that Olama hosts for you. You can pick the one that you want and be able to download it. But really quickly, just to summarize this part, I mean, so Unsloth, ballers that they are, they have Kimi, they have Qwen Coder already. I mean, this literally, just to give you an idea, I mean, just so that, you know, just so that you understand that we're like, you know, we like how recent this was. When did this get released? 1 day ago, right? This one's 24 hours ago. This guy got updated 24 hours ago. The Q8 got updated 22 hours ago. I mean, so this is how fresh off the presses this stuff is. I mean, this model got released, I think, Monday. Kimi got released last week. I mean, this stuff is brand spanking new, absolute, you know, absolute pinnacle of open source AI stuff that we'll be playing around with today. I mean, I'll even go as far as to say I took a look. I mean, some people have a couple YouTube videos. I've not yet found anyone showing running these models. Guys, ask me why. Why do I think people aren't running these models? Could it be that they don't have H200s? Maybe people just don't have H200s. Just, I mean, these poor people without H200s. I mean, what's going on? All right, so yeah, so I mean, that's the story. I mean, I don't understand I've seen this a couple times, like this A35B. I don't know what the A35B is. If somebody tells me, I mean, I keep forgetting. It's like something where in my head I'm like, I need to look up what an A35B means, because it's like a quantization or something like that. But I never find. I always forget to look it up. So I forgot what the A35B is. But I mean, according to the name here, it should be the 480 billion parameter model. So very roughly 480 at Qwen 8 is going to be 480 in gigabytes. So 480 gigabytes. So 480 gigabytes is basically, I mean, so in theory, this model should be able to fit on 3 H200s, but we're going to be running it on 8. So yeah, I mean, we'll have to see. We can try the FP16 for this. We can just try the full-blown model. I'm actually curious if they, so the other thing that they do, the other thing that is pretty baller that Unsloth is doing is a lot of these models are not GGUF, which is essentially a model format. And that's a model format that Llama is normally encoded in. And that's the model format that Llama CPP expects. And so basically, if you go here and you download this from them, this is the BF16, so the 16-bit like latest generation hardware floating point on NVIDIA graphics cards format of this model. And this runs on, I mean, and this is GGUF. So that means you can use Llama CPP, which is nice. Because so we'll let me pull that up as well really quickly. Llama CPP. Llama CPP GitHub. I'll show you guys really quickly. So yeah, we'll let it start loading the page. In the meantime, I forgot, I want to show you guys this as well. So if we go to models, so Olama doesn't have these, guys. Olama doesn't have these. Is it because they don't exist? No, you could actually go and get Olama to download essentially the GGUFs from Hugging Face, write your own Olama file, and it will basically download them. But you would need something like that. So the thing is, models like DeepSeek, they're not formatted GGUF by default. So you cannot use Llama CPP by default to run them. I don't know if there's a switch now, but for the longest time, there was like two worlds. There was, I forgot what the other format's called, or GGUF, and not everything was GGUF. Most notably, DeepSeek is not default GGUF formatted. So if we go and we take a look at DeepSeek and we try to see like what are the, oh man, is it gonna, Guys, I shot myself in the foot. I thought if I have more upstream bandwidth, it's gonna be such a smoother stream, but now it's so slow to download. But basically, I mean, you can see. I'm trying to think. Yeah. Oh, yeah. We got to go to view all. That's the issue. So you can actually see. So this is the issue, is that these are the actual models that you're downloading. So they actually have tags for these. So let me make it bigly so you can see. I mean, there's different. So you can see this is how much the size of them. So that's basically how much of VRAM you need to even load them. But the 671 FP16 model is 1.3 terabytes. So even DeepSeek does not fit on H200s. You would need a Q8 for it to fit on H200s on a single server. So you could run multiple servers. We could run multiple servers. I mean, I could spend the time running multiple servers, but I'm telling you, it's going to add latency. It's not going to be as performant as running just a single server. And guys, we run decentralized servers, so it's going to be a ton of internet traffic. The servers might necessarily be in the same data center. They might not be in the same rack and all this kind of stuff. So it's not worth it for us to run it. From a practical perspective, the best performance that we're going to get, and like 95 to 99% of the actual accuracy of the model, we're going to get by just running a Q8. So I'm going to be showing you running a Q8 for Qwen Coder, and also for Kimi, we're also going to run the Q8 because that will just fit in memory. And the advantage is, so what did I mention? Unsloth again. Unsloth did the work of converting into a GGUF, again, model format, and that means that we can run it with Llama CPP. So cool thing now about Llama CPP is Llama CPP comes with a Llama CPP package. Woo! Llama CPP in the house. So what does that mean? That means that if you're talented and you're not on a Mac and you can run Docker containers, you can do Docker pull ghcrio ggml -org llama cpp server CUDA. So basically the server CUDA is the one that you want that runs a OpenAI compatible API. So I'm literally going to be running this tag. I'm not going to run like the latest 12 hours ago thing, or I mean, technically I am, but just in case, this is the one that I pulled. So I did a Docker pull ghcrio ggml.org llama cpp server CUDA. And then this is just the Docker container, so you can pass all the command line parameters to it, and I'm passing all the command line parameters to it to say, essentially run this model. You have 8 GPUs and all this kind of stuff. So I'll show you guys the command line that I'm running on these servers in a little bit, and then that's what we're going to do. And so we're going to run the Llama CPP Docker. So you can compile Llama CPP from source. I mean, Llama CPP is baller. You can go to the GitHub. It's all here. You guys can basically, I mean, it's all well documented. You can see how to build it yourself. You can build it from source. It's an amazing package. How many likes does it have? It has like a 3,000 releases, 83K stars. I mean, this is like running half of the AI internet right now. So you guys can go and grab essentially this and build it from source. Or you can actually go and run the CUDA container. So also I mentioned that because I mean, yeah, I don't want to load the Unsloth website right now, but the imho, I mean, I don't really, like, don't ask. I mean, it just blows my mind. It just blows my mind. Like, why would you not run a Docker container? I mean, a Docker container is so much easier to run than anything else. So, but technically Unsloth, like if you read on Unsloth's website, they tell you to compile Llama CPP from source, and then to essentially download the models, which, I mean, we'll get into here in a second. And then once you download the models, run Llama CPP from the terminal and essentially do it that way. So I'm not a fan. I would always use the Docker container. Moreover, I mean, hopefully it's not a secret. I mean, I can show you guys like all our Docker containers. So here, wait, let me do this really quickly. I'll show you guys. I mean, we're very open source friendly, and there's a wonderful essentially project of ours on GitHub called C3 Docker images, and these are basically all our Docker images. So WhisperX is here, Trellis is here, RemBG, the CSM Gradio. I actually have, wait, let me think about it. Oh yeah, I remember I was starting to sweat. I was like, did I shut the test machine down? Did I back up what's it called? Did I back up the Unirig radio? Because it doesn't seem to be committed. And then it hit me that yes, of course I did, because I rsynced the files onto the test server. So I mean, they're on my local machine, but it's good that we saw this. Dimitri needs to commit to not be cursing and table flipping and hating his life for losing code that he spent a couple days writing. So I need to make sure I commit it after the stream. It's not committed yet, but it's mostly there. So I mean, we try to publish all this stuff as Docker images. Why do you want to publish it as a Docker image? Let me go full screen. So guys, why do you want to publish it as a Docker image? Because then you can run it on Windows, you can run it on Linux, Everything just runs. It all just runs. It's crazy. Like, I mean, I'm testing these containers locally on my 3090, then uploading it to our Docker registry. All these servers around the world are connecting to our Docker registry, pulling the image that I wrote on my Windows freaking machine, and it just runs, and that's amazing. I mean, like, golf clap to Docker. They did a great job. I mean, and to NVIDIA. I mean, both of those. I'm amazed that I can write Docker on Windows and then write production Docker containers on Windows, and they just magically work on our infrastructure on these $1 million machines. They just work, and then that's pretty exciting. But like, for example, I'll show you guys, I mean, like the comfy UIs here, and we have a couple other packages. I think we need to make packages for, I think we actually have packages. I don't know why it, I don't know why it only shows one. It might be because, yeah, I don't know. I mean, it might just show one. I might not have linked the other ones. We should have at least the Whisper X for sure. I think the Trellis as well, and the CSM. I mean, we should have these as containers somewhere. I just think they're not, like, either GitHub doesn't like you to have multiple things, but basically, I mean, we have containers for each one of these. I mean, you could also just pull the container from GitHub with everything pre-installed and just run these locally, for example, on your Windows machine with an NVIDIA GPU. And that's the kind of testing that we do, because I mean, everyone knows we want to eventually support running this stuff. So I feel like that was enough explaining. Let me check. I want to check the chat. I gave like a lecture on A35B is 35 billion parameters per expert is what the chat says. So I'm actually curious, because I mean, that is there's like a practical limitation. So I noticed this is there's a practical limitation that a lot of Docker implementations will not let you go over 40 gigs per layer. So it's like a practical limitation to do 40 gigabyte file sizes, and so that would match up. All right, so let us do a couple things. No, the Twitter stream went down. My god, why does it do this? This happened last time too. What does it do? It's still going on my end. I don't understand why it does it. Do we just keep going? Do I restart the Twitter stream? Thank you for letting me know. That is so Twitter, why do you do this to me? I think, does it have like a limitation? Do you have to pay to stream longer? It happened last time too. It happened at roughly like 50 minutes. I don't know what's going on. What's like the rationale? Why does it go down? Yeah, I'll restart the Twitter stream. See if we can get it. X, why do you do this to me? X, why do you stop the stream? Why do you stop the stream? Good that I'm recording locally. I don't understand X streaming. Guys, I built streaming before. I don't know why it does this. So yeah, I'll try to get the X stream back up, because we're actually doing stuff now. So that's so lame. That's so lame. Let's just go live right away. So wait, this. Let's just do. Yeah, thank you, chat. So yeah, let's just do. Start immediately. What is it not like? Select a source. All right, so I'm gonna get the X up and running. I don't know why it does that. It's so lame to me that yeah, I don't know why it does it. I understand. All right, let's stream. All right, so it's going somewhere. All right, so I see myself, so we should be good to go. We'll just continue it here. I don't know why X does that. That's just dumb. I have a feeling it happened last time too, and it was literally it's like 50 minutes every time. I don't know. It's just weird to me. It happened at exactly the same time last time. I don't understand. I don't understand. Maybe there's like a limit. Maybe I'm streaming at too high a quality, and we just hit like a gigantic, a big number in terms of data sent, and Twitter just accesses the stream, which would not surprise me. So yeah, so let's keep going. All right, so but I do want to show you guys now that we're back up and running. Let's actually run this stuff. So what I want to do really quickly, just to show you guys. So let's do the following. Let us do the following. Yeah, I mean Twitter, yeah, X. I mean, I don't know why X streaming sucks. Like, I don't understand why it does this to us every time. I mean, I also like YouTube has superior streaming, unfortunately. I mean, Dimitri's pretty good at streaming. I mean, we could run our own streaming, which I'm like, speaking of which, I was like, I saw people were calling out Pump Fun for not streaming their interview with the thread guy or whatever his name is. So I was pleasantly that tickled. As somebody who's built streaming backends, I was tickled to hear that people, once you've built a streaming platform, you get called out for not using it. So I agree. I completely agree. All right. So Open Web UI. Oh man, pretty baller. Shout out to people in the chat who will appreciate both of these sponsors of Open Web UI. So I did want to show you guys, just because people bring this up. So what I want to take this opportunity, at least with Kimi, to also show you guys a couple tricks, which is there's an expectation that you actually have to like. So we're gonna run an OpenAI compatible API. So what does that mean? It means I don't have to, I mean, I can hook up stuff. Like if I need a web interface and I want to use this, I can hook up my own web interface. I can run a web interface. I can do all this kind of stuff. So basically I can use Open Web UI and we can actually run it locally and do all that kind of stuff. So I'm here, wait, let me think about it really quickly. I want to see if I have, do I have a llama? I do not have a llama, which is perfect. So then, and then let me check really quickly. I'm going to check. Do I have I'll just show you guys, like, I mean, how I would do the development on this, because I mean, people ask for this. People are like, Dimitri, you do more of this stuff, show us magic things. So I'm gonna show you guys magic stuff. All right, so I just want to see, no, but it looks good. So I don't think I have I don't have the container, so I have a separate, like, for streaming we have like a separate Windows now, like a separate Windows install. So I don't have any of my build stuff here, so we'll have to install it really quickly. But basically, here's what I'm gonna do. So I'm using Open Web UI. Open Web UI is just gonna be a web UI, and we can tell it to different server to with NVIDIA GPU server. So this is the one that we want to probably run, and then yeah. API usage. Actually, that one's not terrible either, because we could use. Anyway, I'll use this one because I know I have an NVIDIA GPU, so this command's gonna be fine. So we should be able to run it and essentially run. Oh man, but now my internet. Let's see how long it takes to download. Worst case, if we can't download it here, we'll run it somewhere else. So let's just give it a shot. But I might be internet limited today. So I'm gonna try this command. Let's see. Let's try it. So it's gonna say unable to find. Let's see how long it takes to download it. If it takes too long, we'll call an audible. We can actually run. We can actually use the other one. Oh man, that's pretty. All right, let's see. Download. Oh, I must have downloaded it. So, but it might have to still download Llama. Let's see how long it takes. We'll see how long it takes if it gets it up and running. Well, we could also actually do so, just to show you guys. So I'm actually going to do the following over here. I'm going to kill this guy. Let's just launch I mean, it doesn't matter which one. Let's just do a coder. Let's do it for like 3 hours or whatever. We can actually use one of these instances and just use its front end to add like the API URL for the instance that we have running, and essentially be able to use that. So let's see. So yeah, this one's gonna, yeah, let's just stop that. My, unfortunately, like I said, I'm doing a tunnel. I got, because let me go full screen for this. So Twitter, freaking X, why do you keep doing this to me? I'm running a tunnel today because X crapped out last time, and after 50 minutes, stopped the stream. So what I do today, I set up a tunneling my internet connection to essentially a server on the internet in the hopes that we'll have a more stable connection. What does X do? After 50 minutes, it terminates the freaking stream. Come on, X. What is going on there? What is going on? If someone knows why X abruptly ends the stream, is there like a 50-minute limit on X? What is going on? Come on, X. Get it together. So anyway, we can run it. We can try this coder instance. We'll just connect to the UI. It's going to take a little bit of load. Oh, but we might actually even be on the same machine as before. Not sure, but it loaded pretty fast. So what we can actually do here is if we go to the admin panel and settings, we can actually... we should be able to connections. We can go over here and we can add OpenAI API connection. So we should be able to add a connection right here. So what I'm going to do, quote unquote, off screen is, and then when you do add a connection, you have to go to configure and you have to say which models are there. And then you have to type them in. And the way that you type them in is like, so you say like GPT-4 and then you hit plus and then you hit save and then it saves it. And then you can use the GPT-4 model. So in our case, we're probably going to have to curl and see what the models are. And I mean, yeah, I'll show you guys. I don't want to like reveal the URL. I mean, so you guys are going to have to hop on the Discord to get the URL of the instance that we're running today, which is up and running. But you guys, I'm going to post it in the Discord after the stream. So for you guys who want to play around with it, you're going to have to check out the Discord for these URLs. So I'm going to hide them. But I'm telling you, you can add it here. There's also something called continue.dev, which we'll play around with. Continue.dev. And let me see, do I have Visual Studio? Oh, so I do have Visual Studio Code here. I don't remember, I don't remember if I have it here or not. If I have Control Shift L, view, window, go, terminal, what? 1 second, I want to see if I have it. I should have it here. What is it? Shift Control. Oh no, it's Shift Control Shift I. I don't think I have it installed. Is the problem? So yeah. So I'm gonna install. Or actually, no. Do I have it? Wait, it was just there. Dang it! I should show you guys what I'm doing here in a second. All right, let me do container tools because that's a good thing to install. So I want to see. Do I have continue installed? I think I might have it installed actually. Continue. Let's see. So there's a extension for Visual Studio Code that you can use that should work great with this, which is called continue dev. Dev containers. All right, and then continue. Wait, come on, give me continue. It's slow to load. Oh my God, this internet connection. It's slow to load right now. But the continue dev. Basically, we can install continue dev, and then we can use continue dev to essentially get the to connect it as well. But the first thing that I want to try is I just want a web UI. So let's just abuse the fact that we have that server, that other server that we can use, and we can run everything there. So what am I gonna do? So I'm gonna go over here. I know what the URL is, so I'm gonna pull it up really quickly because I have it in my I have it up and running over here. So let me actually check. I want to check what the model name is. So I'm gonna do the following. So wait, I'll pull up a new video just to show you guys. Let's do okay, and then I'm gonna do clear. Do this. Can I do? Right? Can I hide this somehow? Here, I'll try to get it off the screen. So I did curl. So I curled the instance that's running, and we can see here's the model. Oh man, is this a freaking name? Are you kidding me? Oh, that's the model name. So it's good that I checked because this one would have would have been tough, but it looks like the name, Jesus, the model name is going to be this, which I mean, I didn't know that's what Llama CPP does, which isn't great, but the model type, model description, I kind of feel like let's do a, right, do I have JQ? I got a sudo apt install JQ. Let's do that really quickly. I'll install JQ and then we'll take another look at it. All right, we get installing JQ over here. All right, so we get JQ. So now I'm gonna do echo. So wait, let's do that, and then that'll work for sure. And then we can do JQ, so we can take a look at it. Yeah. Oh my god, I didn't know that that's the case. So unfortunately, it looks like this is the model name. So that's what we're gonna have to enter. Apparently, but I mean we can actually do it. So that's the path. That's like a relative path. I mean that's the path inside the Docker container to the model. I mean I'm sure there is a way to specify the name, but we're not specifying the name right now. But this is running, so let's actually give it a shot really quickly. So I'm gonna hack that into my thing here really quickly. I'll show you guys what's up. So yeah. All right. Yeah, I just saw. I mean, anyway, we have the URL might have been on the screen a little bit. So I mean, yeah, screw it. I'll show you guys. It's not like I'm not trying to hide it. I mean, this is going to be the URL. I mean, we'll leave it up and running. So if you want to get all this, you can find it. You can find it afterwards. It's not like a big secret or anything. I'm just not. This host isn't going to stay up forever. Is what I'm trying to tell you guys. So what am I going to do? I'm going to go over here. Let's hit plus. I'm going to do API base URL. Let's try this one right here. Let's actually give it a shot. Because now I'm curious to, now that I've revealed the URL anyway, let's actually try to debug this real quick. So we have this guy right here. We're not going to have an API key. And then let's go back over here and try. This is the freaking model name. So let's try it. See if we can get this to work. So I'm going to hit this right here. Model IDs. Let's try it. Boom. Plus save. Okay, see if that worked. Now let's do new chat. Oh my god, there it is. It's filling up the entire screen. And let's say hello, and let's see if it works. Yes, yes, boom, we got it to work. So unfortunately, I mean, all this stuff I'll share with you guys, but this is going to be unfortunately the way the Llama CPP is running. This is apparently the thing. So I mean, now that I revealed, I mean, I was thinking I'd be cute and not show you guys. So what am I doing? I mean, it's running a full-blown API. So what does that mean? We can actually go and we can curl it to see like what the model names are, and we get a JSON back with like the model paths and stuff like that. So it's like a standard V1 OpenAI V1 API. So we can actually play around with it. So if we go now, let's do some more tests. So let's say, write me a 1990s single page HTML with lots of blinking. Say that this is my amazing blog. And then the other thing that I would do right here, just in case. So let's set. So a couple things I remember. Temperature, it actually set a set to 0.6. And let's set the num tokens or num CTX. Let's also set this to I don't know, 120,000 or something like that. Should be fine because it should fit in this model. So let's give it a shot. See if it runs. There we go. All right, so we'll take a look at what it actually goes in and generates. We'll take a look at the result that we get, but this is, you know, it's running this, and actually in the meantime I'm gonna connect to this instance. I'll do it off screen really quickly. So wait, let me try to think of the best way to do it. All right, I have one idea on how I could show you. I have an idea on how I So I'll show you guys. I mean, so good already. I already see marquee and all the elements that you would want to have are flying across the screen. But I mean, this is like, I mean, this is always so baller to me that when you're working with AI, that it just like it just spits. It knows what it knows. It just hard coded knows the like just some gigantic. It just knows some base 64 encoded GIF that would be perfect to insert here. I mean, what a baller, what a baller. So what I'm gonna do, so yeah, so I gotta do, I'm distracting myself just with how epic this is. Let me do, God, everything's loading so slow. I wish I didn't do the tunnel. Twitter freaking X still disconnects, and I did super slow tunnel because I thought it might be more stable, but it's not me, it's X that doesn't like these streams. So it should be done here in a little bit. But you can see, I mean, you do benefit from I mean, more GPUs can be more better in terms of the speed, but that's pretty good. That's pretty good already. So there we got the result over here is the website that it did. The marquee, I mean, so hopefully you guys do not have let's just say the blinking is way too fast. Oh, it suggested MIDI in the background and all this kind of stuff. Sign my guest book. I mean, let's see if it fixes the speed of this, but it's already a pretty good coding test. I mean, it does a decent job. So we can compare this. I mean, this is like one of my favorite coding tests where, I mean, it should be able to do something like this, something as ridiculous as this, and give us a result. So we'll see when it's actually finished. Did it think that it's fixing? No, it's still going. It's still getting the response and everything. So let's see it do it. By the way, so one thing that I can tell you guys, which is going to be essentially an issue. So I'll go full screen for this. So the instance is behind Cloudflare. So Cloudflare has a 1 minute 40-second timeout. So if it takes longer than 1 minute and 40 seconds to generate the response, you're just going to have whatever front end you're working with error out. And it's pretty typical. I mean, we can go back over here. So let's go over here. I'll close this. It's usually pretty common for I mean, yeah, perfect. I mean, this is like exactly what I want to show you guys. So it's basically when it's doing the oh yeah, but it's doing a server side request right here. So we don't actually see what the query is, but it's pretty common. It's pretty common for it to not have it's pretty common for the blinking or like the query to time out. But that's like a Cloudflare thing. So I'm not gonna, I mean, when we run the production thing, we'll have like a nicer solution for that. But for now, you guys are just gonna have to deal with it. So if you wanted to like one shot gigantic code, it might time out, and that's not because the model can't do it. It's because we don't want it to like one shot. I mean, we want to have some limits. Otherwise, you guys are just going to go absolutely crazy, and then we won't be able to use this. But you can see, I mean, I'm running an open web UI. We connected it to this model. I want to connect to the machine and show you guys that we're actually like loading up the machine and stuff like that. So I'm going to be able to do that in a second. I just got to pull up, I got to SSH in basically so that we can see it, because this is a test machine, not a production machine. And then we can play around with it. And then I'll also essentially log into the second machine, and we can get that up and running. And then we can actually play around and run like multiple models simultaneously and stuff like that. So yeah, so I mean, it's still going. So when, I mean, when you actually connect and they're running like, I mean, on something like Claude, etc., they're actually running a cluster. So you do usually have multiple GPUs. They're connected with a super high-speed link, and so you will get a little bit better performance just for tokens per second. But I mean, this is still pretty good. And this machine, there is, so I have to see. So you see right here, I have a feeling, I don't know if it's finished or not. So I have a feeling that it did not finish. So we could tell it, we could try. So I have a feeling that was exactly what I was just describing with the timeout. We can tell it to continue. It should figure out that it did not finish, and it should just give us the second thing. But then we might have to render the file outside of it. So yeah, so here it's going. I mean, it's like it's literally continuing and finishing it. So that's like the life hack that you can do. But unfortunately, I mean, even this website. So it's basically. I mean, I'm telling you, the timeout is the timeout that we're hitting for this website generation is. I mean, that's pretty good. It's doing links to GeoCities and Alta Vista and Angel Fire. I mean, what a baller, guys! I don't know how old you are, but I mean, this is me middle school right here. I mean, I just feel like it's hi, I'm 13. I'm 13. This is my first webpage. I mean, this is pretty good. It's pretty good. So unfortunately, like the UI that we're using, it will not. I don't know if we can tell it to collapse or combine these files. I think I would have to copy them out of here, create a single file. But it was smart enough to realize that it stopped right here. And so when I told it to continue, it's actually generating the rest of the file from where we stopped. Counter and MIDI, it's like inserting midis and stuff like that. I mean, that's pretty good. I mean, so I'm already impressed. I mean, the first result was not bad, but unfortunately we timed out against Cloudflare on the second one, which, like I said, I mean, for testing, deal with it. For production, we solve this kind of stuff, but basically we need a load balancer on top of it. So we're not giving you direct access to the GPU without a load balancer running on top of it. So we're going to put a load balancer there. The one thing that I did forget to say though, which is worth saying, is when you run a model like this, usually the way the models are designed, they're designed for simultaneous queries. It's not like one person can run this. So somebody could actually, you know, be doing queries in parallel to me, and the model will handle it just fine. So you can see it's showing us HTML, but it's broken HTML code because you actually need to combine these two files to get the final result. But basically, I mean, it did slow down all the animations. I can see they're not like as crazy, but unfortunately this right here is just part of the code. So it's not, this was like the original one, and actually managed to crank out the full website in a single go. But hopefully no one has epilepsy on the stream, because there's a lot of blinking going on pretty fast. I'm not responsible for the AI generating epileptic code. Okay, so long story short, I mean, it's working. I'm pretty happy. So I do want to show you guys. I do want to log into the machine. I'm just so triggered by all the stuff going on right here. I do want to log onto the machine, so I'll show you guys what that looks like. We'll run NVIDIA SMI so we can see how much of the model is actually getting used and all that kind of stuff. We'll play around with it. So I would be here. Wait, let's do here. Man, I'm so mad. I'm so mad that I spent the time building like a tunnel for today. That I spent the time building a tunnel for today just so that the X stream would not go down again, and then it went down. So it did not help King X. I think I have to stream at a lower quality. I think we're just like sending, like, the quality is too high on the stream. Just have high standards. We should be streaming at a super low quality, and then it'll be happier. All right, so cool news is I can SSH onto the machine. So I'm gonna do that really quickly, and then I'll show you guys once I'm logged in. All right. All right, so I'm gonna show you guys. So this is me on this machine. Oh my God, now everything's open. So this is me on this machine, on this test machine. So let's go back. Let's go back. So this is me on this. Oh yeah, so perfect. I didn't. I was moved over. This is me on the test machine. So you can see this is actually the Llama CPP. So I'm actually running a Docker Compose just so we can get HTTPS. So I'm running a HTTPS reverse proxy. Just so that we're not running HTTP. So at least if you guys want to try it, it's at least HTTPS encrypted to this backend. So that's all happening through Cloudflare, transparently, all that kind of stuff. So I do want to show you guys. Let's just run NVIDIA SMI on here, and we will see we are running on this machine. You can see there's 8 processes, 1 per GPU, and we actually have 1, 2, 3, 4, 5, 6, 7, 8 GPUs. So 0 through 7, and we roughly have anywhere between 125 gigs out of 144, like 109 to 142 out of 143. So I mean, we're filling up the GPUs pretty legit to have them up and running. I mean, so that like keep that in mind. It is actually taking up this much of the GPU. And if we actually go, and so like let's go up here, so over here, let's just do, so what we can do is, I think we have to go to the bottom of the response. We can just say regenerate the response. So I'm going to do regenerate the response. Actually, let's do this. Let's pull this guy up, and then let's move this guy over here. Boom. Oh my God. No, not the website. All right, so I'm just gonna say regenerate the response, and then we can basically just run NVIDIA SMI a couple times over here, and you can see it's already at 13%. Oh man, even this NVIDIA SMI is too slow. Yeah, but I'm also still downloading that Docker container, so it should be a little bit more stable now. So wait, let's try it one more time. So yeah, so you can see, I mean, here's like it's trying to show us something, but here's it's using, I mean, so this is like typical, like when you actually have the model spread across the GPUs, it's not actually capable of using the GPUs to like 100%. Oh my God. Can I not, can you not close? Can you not close? I mean, it's generating and trying to render the website, so that's why we get a black screen over here. But in the meantime, it's outputting code underneath. So that seems like, all right, let's go full screen. So yeah, I mean, you can see it this way. It's just the, can I do it like that? Is it gonna work then? Yeah, I think it will. So it's generating the response, and we can see it gets up to like, I mean, it is using all the GPUs. There's no GPUs that are idle, but it's not like they're maxed out. So what that also means is that if somebody did a second query in parallel, it would actually be capable of loading up the GPUs again and all that kind of stuff. And you can actually see here like that it's, even though it's going as fast as it can for this one query, it's nowhere near like loading the GPUs. And technically, I mean, we could also, there might be some parameters that I need to tweak where I just pick the standard parameters, but there might be tweaks, like for example, telling it, specifying what sort of key value cache it should use, what kind of sizes, all that kind of stuff. So I mean, I'm gonna tweak that stuff like at a later date, but like this model would not have loaded if we didn't have 8 H200s. Like it wouldn't have fit into memory. So this is like the key thing right here is memory usage. The fact that this guy fits at all is like, I mean, it's only because we're running on H200s, because they're all basically full. So this one's like 90% full. This one's a 100% full, 100% full, 90% full, 100% full, 100% full, 100% full, and then this one's like 60 or 70% full for whatever reason. But basically, I mean, that's how it does it. And then look at these GPUs. They're 700 watt GPUs, just to be clear. I mean, most people, that's what you use in your microwave. I mean, when you're trying to cook something, and then we have 8 of them just to run this freaking model right here. All right, so I mean, that was I mean, we can try, I would try some other stuff. So basically what I want to do right now, or what I want to, so I'll go full screen really quickly. So what I'm going to do right now is I'm actually going to log into the second machine, and I'll show you guys getting everything up and running, just so we can play around with it. So basically I'm going to log into the second machine. Let's do, all right. All right, and I'm gonna go to wait. All right, so I'm gonna go into here because I know that I have a lot of room. Actually, let me do the following, because I'll do this, because then every session that I launch in tmux from here. Perfect. All right, so what am I gonna do? So we're on the second machine. So again, second machine, we also have NVIDIA SMI here. So just to show you that it's a second machine. RAM usage, also all H200s RAM usage is absolutely 0. So this machine does not yet have the model that we need, so we need to download it first. So for downloading the models, let me see if I can pull it on Unsloth. So let me show you really quickly. So Unsloth has it as, I mean, let's do like Qwen free coder. So I had it. Yeah, so I'll show you guys really quickly. So basically, I mean, I'll even go full screen for this. If you read, so basically, blah 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 blah. Qwen coder, how to run it locally. So locally is a strong word. First of all, locally is a strong word. I mean, I'm running it locally. So they say, so basically, what do they say? Here's how you run it with here's how you run it with Llama CPP. So Llama CPP has a downloader built in, so you could call it like this. The problem is that downloader is single threaded, and we have to download like a terabyte of data to be able to run the model. So you're basically just guaranteeing that you're going to be waiting forever. So the nicer way to do it is to use the Hugging Face Hub Python package, and the way that you use it is you write a little piece of code like this, and you tell it what to download, and then it goes and it downloads it, and then you tell it like download this pattern. So you basically tell it like, yo bro, download a Q8 for me, and then it downloads a Q8 for you, and then we should be able to get it up and running. So I basically did it, and then you can specify like run this code, but I'm doing it in Docker container, so we'll adjust really quickly here. So for that, I mean, I will admit I have it open, and we'll get it up and running. I'll probably revert to my Claude window where I was tweaking this to get it up and running, but we'll try it here in a second. So I'm gonna get a couple things ready, and then we'll start downloading the Qwen coder model. All right, so let's do the, so I gotta install, I still have a, uh-oh, right, is it, oh, yeah, the stream's going, I don't know, I have a, it's like as if, it's like I lost my connection, which is slightly annoying. Let's try this. Yeah, let me close, I gotta close a couple windows, get it up and running. I think I am having a WSL2 issue potentially. So let's see. If it doesn't work, we can SSH in from PowerShell, which, I mean, that would suck. So I'm having now I'm having like another issue. All right, let's see if we can get this. All right, so that does work. The problem is, all right, let me try. I'll try something really quickly. Oh my god, my PowerShell, I don't know what's going on. My something died. WSL died somehow just now. Let me try. So WSL is not loading. So I was trying it from WSL, so oh my god, so annoying. All right, let me try. Let me do the following. File. Yeah, something died in Windows. Let's do. Let me do the following. All right, perfect. And then, oh man, that's actually, wait, I have a good workaround here in a second. So let me do open file. Wait, I need like 1 minute, guys. I need 1 minute. Please wait. All right, perfect. I got a good idea that we can do here. So let's do the following. I got a thing over here. All right, and then let me try. So let me see if I can get in. I can't believe WSL2 died just now. I mean, that was what a time to die. Let me try if it works. Oh my god. See. Let me try one more thing. I'll do one more thing. All right, let me try one more thing. Otherwise, I don't know. I don't know what happened. My WSL just stopped reacting to keyboard input, so which was super annoying, of course. Let's try this. It's not letting me log in. That's so annoying. Is WSL gonna come back? Oh my god. Yeah, WSL crashed. Oh my god, WSL crashed. I'm trying to think of the most reasonable way. I'm trying to think if we can, if there's like a quick way that we can do it. Let me try one more time if I can get WSL to reboot. Yeah, I mean, oh man, I wish I wanted to show you guys my I don't feel like rebooting the stream just to get it up and running, because it's like not connecting right now is the problem. Let me, I mean, yeah, if it doesn't work, then the last thing that we'll do is let's restart WSL2. I want to see if there's a good way that I can do it. Yeah, so I mean, let's see if we can get PowerShell to restart my WSL2. Yeah, I mean, it's a I got a weird error, so let's try it. We'll try one more thing, and then if it doesn't work, it doesn't work. So basically, I'm gonna try WSL shutdown Ubuntu 2404. Let's see if the Windows does it have a higher chance of working. Oh, and then I had it put over here. I have a feeling it's not gonna work. Yeah, maybe I should try the restart service thing. So yeah, let me try it one more time. Otherwise, guys, I don't want to reboot my machine. Unfortunately, WSL crashed on me, which was terrible. I mean, yeah. Anyway, I'm too lazy to, guys. It's not I'm not gonna. We're not gonna. I mean, unfortunately, if it died, it died. I'm not gonna do anything crazy, but let's just see. Let me try. Yeah, I have a feeling WSL crashed. I wonder, can I do and it might have actually been because of Docker, because Docker also uses WSL. So unfortunately, it happens. Let me see if I can do, because I don't know if so wait, let's try. Yeah, guys, unfortunately, I think I gotta reboot here, but then we're gonna lose the stream. So let's do. I mean, anyway, here's what the plan's gonna be. I'm gonna get. We're gonna. As promised. I mean, I'm gonna like I'm gonna reboot and get this up and running. So tomorrow and probably until Saturday at least, we will have a way for you guys to join our Discord, get the URLs for all this, and play around with both models. So we're gonna have both models up and running. I'm not gonna be able to boot Qwen Coder on stream. That was the one that I was gonna demo booting on stream. So the Kimi I got up and running essentially like the hour before the stream. Qwen Coder, I'm not going to get up and running right now because I need to stop the stream, reboot, restart the stream. So we're not going to do that. It's going to take too much time, unfortunately. So I will get it up and running, though. It's not, I mean, it's not a question of if. It's a question of how long do I need to get it up and running. We're going to let you guys play around with it. So you can integrate it with Open Web UI and play around with it. Get it up and running with Open Web UI. You can get it up and running with Visual Studio Code. You should be able to get it up and running with Cursor and everything else. The coolest one, so this one I'll actually show really quickly. So the biggest thing that I forgot to mention about these models, which is worth mentioning, is the problem was last year when these models came out. So essentially these models, the coding models always come out late July, early August. I mean, that's just been the case for most of the coding models, at least the Chinese ones. That's just when they come out. So mark your calendars. This time next year will be the next generation of these models that comes out. So the cool thing is, if you go and you actually grab these models, I mean, so if you went, or like last year, the problem was they came out last year, and then Claude Code and Cursor, etc., and MCP and all this cool stuff came out, and then basically they just became outdated right away. They became outdated because MCP came out, because tool use came out, because all these niceties got integrated into the frontier models, and all of these models that were being trained through the beginning of next year just didn't have them. And so normally that would not be the case, right? It was like these like stellar, super important features came out for Qwen Coder and everything else, and they just weren't available. So this year, all of these models have like number one feature, tool use, number two feature, MCP support. So all these open source coding models now have tool use and MCP support. So you should be able to do super epic stuff with these models. They're well aware of tool use and all this kind of stuff. So what does that also mean? That means so wait, overload base URL. So I'll try to find the thing. So basically I haven't tried this yet, but I saw a couple. I'm trying to find so yeah, so basically, so I mean, essentially what you can do with Claude Code is you can tell it what the base URL is. So there's a URL. So you can overload the base URL. And there's like a couple ways to do it. I saw this Reddit. Oh my god, I gotta log in because I'm tunneling through a server right now. But basically, you can set your Claude V. Is there a URL here? There's a URL that you can set, API based URL. Here we go. It's right here. So you can, with Claude, you can set, you can override this base URL and point it to our server. And then you can also set an API key and stuff like that. So you can tell it to not use Anthropic. So you can take Claude Code, tell it to use our Kimi, and it will work. So I haven't tried this, but a bunch of people have tried it. So this should work. So you should be able to do that, essentially to override it. You can even, so you can set it. There's a couple tutorials on how to, on people doing it, because essentially the like preferred way to try and use Kimi right now is to use the Kimi API, use their API tokens, and essentially pass the URL and tell it to point to Kimi. So right now, the way that we're going to run it, there's not going to be authentication or anything. I mean, so you could set like a API key, ignore the API key. I mean, we're not going to use the API key. I mean, you might like do it at your own risk. I mean, I'm telling you, we're not going to sniff your API keys, but technically, like if you do the default settings, it might be setting your API key to our backend. Just like be aware. I mean, just like I said it on the stream, that's your thing. But basically you should be able to override it. And then so it's here like Anthropic API key. So you can export the Anthropic API key and the base URL. You can just do like in terminal, you can say export and then they should work. Oh Oh my god, no way. Oh my god, WSL rebooted. WSL rebooted, guys. Guys, we might be in business. We might be in business again. All right, wait. If I can connect right now, if I can connect back. I don't know what happened. WSL crashed and it just stopped, like my SSH sessions and everything just died. So wait, let me see if I can log in, then we're back in business. I can't believe it. I thought last thing I'll do is show you guys like, oh yeah, it worked. It freaking worked. I can't believe it. We're back, guys. We're back up. So we'll give it a shot really quickly, but I don't have a super high expectations is what I'm saying. So I mean, let's try to so I mean, I'm not going to show this, but like be aware that you can use it with Claude Code. So you can tell Claude Code to use this as the backend and it should work. So really quickly, let me get set up one more time over here. So we should be on this other machine. So I'll show you guys. I mean, let's just do it super. I think like both these models are going to be good. We're going to have to do some testing on it. There's limited testing that I can do. What I can show you guys is like getting these kinds of environments up and running. I think is what people were asking me for in a DM that I've never seen it before, like the work that goes into it. So I'll show you guys a couple things. So we'll try to get it up and running really quickly. So first thing I'm going to do is I'm going to do sudo apt install python 3 vnv because that's not installed yet on this machine if it's a brand new machine. So we're going to need a Python virtual environment to like cleanly download this. The other thing that we should do really quickly, so let me go full screen for this. Let me go like this. The other thing that we should do is from Hugging Face, let's get the so I want to browse this really quickly. So I'll show you guys what I'm doing. What I want to do is so here's what I want to do. I want to grab the Q8 from over here. So right here we want to grab the Q8. We can actually do, I mean, yeah, let's do the BF16 just for fun. So or wait, does the Q8 have a different name? Okay, yeah, so the Q8 has a different name. So let's do files. So there's a Q8. I mean, we could do Q8 or BF16, doesn't matter. Let's go to the BF16 and then so yeah, we can do it like this. So the thing is, I have a Claude session already open with this. I'm just gonna tell it that this is the model that we want to download now from Unsloth, and it should be good to go. So let me pull that up really quickly. I'll show you guys what I'm doing because it's gonna. We basically have to write a download script for all these models. So I'm gonna pull up the previous chat that I had because I already had it all written there. So what I'm gonna do here in Claude is I'm gonna say let's move over here and let's do PC one more time. I'm gonna say let's download and I'm gonna paste, oh, it's just doing the BF16. Still have it open somewhere. Where's my Hugging Face over here? Unsloth. All right, let's do that. And then over here, let's download this. Give me an updated, I know you guys can't see it, I should do it over here maybe. Let's just do full screen. Give me an updated download script in Python. So it should give us an updated download script in Python because that was step number 1. So how did I do this? How did I get it up and running? I mean, I just took the documentation and spit it into here. So yeah. So no, wait, what are you doing? Right, but there was a better script. No, just go off of the example Python HF download script we had at the beginning. Just change the URL. This is still Unsloth. All right, perfect. All right, here we go. Boom, boom, boom. Yeah. All right, perfect. So it should be able to download it right now. So I'm gonna click copy right here, and that's what we need to paste into our terminal. Here's our terminal. So I'm gonna do a make dir hf underscore download. I'm just going to create a directory, hf underscore download. I'm going to do a, let's do Python 3 minus m vnv. Let's do a source vnv bin activate. And then I'm just going to edit this script right here. It's called download py. Let's do that. I'm going to do set paste. Boom, 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 boom. And now I'm going to run it because I can't remember what I'm missing. And it's going to complain that it needs. So let's do pip3 install hugging face underscore hub. Boom. It's going to download all this crap. Let's do it. Let's run it. And then it's still going to miss another thing, I think. No, there we go. So it's going to download these. So you can see it's downloading 8 of them it's downloading 8 files at some high speed. So it's going to download them. I mean, it's going to take a couple minutes, so like 5 to 10 minutes to actually download these models. The other thing, I mean, I'll share it on the, I mean, if you guys want, I can give it to you on the Discord. But basically, I have a Docker Compose, so the Docker Compose runs a Traefik. Traefik is a reverse proxy. It's a Go reverse proxy that does HTTPS and stuff like that. So it's just doing HTTPS, and then it runs the llama in the same Docker Compose on 8080. And so the reverse proxy is actually doing the connections on there. But I mean, just to be clear, guys, so like, let's say each of these downloads is going at 130 roughly megabytes per second. That's a gigabit per second. So we're downloading at like 10 gigs per second right now, all of these files in parallel. So this is like a downloading from the internet at 10 to 20 gigabits per second. And I mean, just to give you an idea, you probably do not have a 20 gigabit per second internet connection at home to be able to download these models as fast as it's downloading right here. And you can see, I mean, I don't remember if you guys remember, but I said like 50 gigs is like a good layer size. So all these try to be less than that. So yeah, anyway, it's going to download and then we can actually launch this, and I'll show you too, and we can try it let's just get it up and running. I mean, it's going to need a little bit to download. I'm going to use that really quickly, that opportunity. Let's check the chat. Check the chat really quickly. I know we were kind of running. Oh man. Performance of Kimi was pretty crazy. That we now have access to open source models and Claude code, etc. Yes, we back. Yeah, so the Claude code, guys, the Claude code, we lost too much time with WSL crashing on my machine. I don't know what happened there, because I think so I ran WSL minus shutdown. I think it actually, what I did was off the screen, but it didn't work right away, was I went into Task Manager on Windows and I killed all the WSL processes with just ntask, which is not a good idea. You should not do that, but I mean, it worked. I think it eventually rebooted WSL. But it didn't do it right away. But then, like, I saw in the corner my terminal window finally opened, so I think we actually managed to restart WSL, so it did come back up. So unfortunately we lost too much time. I was gonna do a Claude Code demo. We lost too much time. I promise you Claude Code should work. I haven't tried it yet, but I'm very confident because I've seen so many examples on online of people using at least Kimi, but I cannot imagine that it doesn't work with Qwen Coder. So I've seen so many people use Kimi with Claude Code that just using the Kimi API, it should work out of the box. I mean, we already got it. We verified the model works. We had it running in Open Web UI. It should work just the same. So what I'm going to do really quickly on the side while that finishes is I'm going to log on to the other machine. And I will show you guys SSH into the other machine. And what I'm going to do is I'm going to, so I'll show you guys how it's running on the other machine, just for context, in case you guys are nerds and you want to see. So really quickly, I mean, I just have I don't think I don't think it's not going to be here. So yeah, so let me just do clear. So I'm going to go to opt DLMI NVMe. So it should be here. Do we have, yeah, we have a Docker Compose here. So, oh crap. No. No, wrong thing. Let's do a Docker compose. So we have a Docker compose here, and so what is happening? I know the colors are a little bit annoying, guys. I don't feel like changing the colors right now just for the stream. But basically, we have basically we have a tray fix. So this is a reverse proxy. Then we have a Llama CPP. This Llama CPP loads particular models. So like these guys right here, it's going to. So it's loading not only, so it's loading these models, but where do the models come from? They come from HF download models. So that's exactly what we're going to get over here when it's finished. So if I go over here, we have HF download, and then in here, okay, so the path we're going to have to update. So it's going to go unsloth. Okay, so it's going to be slightly different. It's going to be like unsloth quencoder here instead of just quencoder, etc. So we'll have to adjust it slightly, but basically that's all we need. So then you have to give Trafic a host name, so it's gonna listen to that right there, and then it's basically gonna forward it, and it's just gonna work. So, and then here I'm passing, context size. I didn't see this, so this is actually not optimal. So we might have been overloading the context a little bit. So you should be able to, this model, so Kimi's 128, quencoder, which is why I'm more bullish on quencoder, is apparently 1 million. So, but like your mileage may vary, so try that. The other thing is with the GPU layers, I would check the documentation for all of this, but basically this is just running Llama CPP, doing all that kind of stuff. So we should be able to steal this pretty much as is over here and do a cd vim. Let's do a Docker compose over here. So I can share this if you guys want to play around with this. If you guys want to try to run it locally, you should be able to run it pretty much as is, just with. Oh yeah, I forgot we got to do set paste because we're in tmux over SSH. Set paste. Boom, boom, boom. So I'm gonna paste it in a place. There we go. And then instead of so let's change this one. So this one's not going to be Kimi, it's going to be Qwen coder. Oh yeah, host name. Yeah, that's hilarious that it has a host name up here, but then it doesn't actually use it. So it should use it should have used the parameter host name, whatever. It's not doing it. So whatever. Let's do, so then the path, so let's do, I don't want to like second guess it. So what I want to do is I'm going to do over here, I'm going to go to cd. So let's go back. All right, let's do opt nvme here, and then let's do tree, and tree we have to install. So let's do sudo apt install tree. And then, so yeah, we need it. I just don't want to do the path incorrectly, so we'll let Claude answer the path for us. So you can see it's still downloading here, by the way. So we'll wait for it to get up and running. So let's do tree minus L. Let's do like 5, and then let's do HF download. I feel like it was up here somewhere. So yeah, there's the models. I'm just gonna say this is on another machine. What should my Docker compose look like? This directory structure. Boom. Go for it. Yeah, I mean, I have a feeling. Here, wait, let's do this just in case. So yeah, let's do, because I'm not sure. It might have been just to be 100. Oh yeah, it's broken. That's annoying. So let's do an ls really quickly. Let's do ls. So it's like hugging. It's hf download unsloth. So yeah, let's just paste this because it's gonna know what's up. No, go back. So here, let's do this. 3. right, so it should know what's up. Actually, let me do one more thing, just so that just to cheat. Let's put it in opt DLAI and then NVB is the directory. So let's try that. All right, and then we'll just paste this one into place, and then we can change around. The rest will essentially work. Oh, parallel. Oh. Wait, let's do. Maybe the parallel was off. We have 8 GPUs. I didn't see that before. Maybe that was going off. We have 8 GPUs. At least be 768K. Let's see. Let's see if we can get that to work. I'm curious if this will work. That might have been the issue with I mean, Kimi might have just been running on 4 GPUs right now was the issue. So I don't know. So let's see. I'm actually curious. I don't think I don't know. I haven't. I usually use oh, parallel request. So yeah, so the MP yeah, so that was exactly what I was talking about. The tensor split might be what we want. I think it's fine. So it can handle basically 4 parallel requests. So let's ask it if it's automatically max GPUs. Because we're passing. Yeah, anyway, whatever. I don't trust it. I think the 4 was probably fine. We just need a bigger context size. So I'll change it. We got to change the parallel. Yeah, actually, wait. Let's edit this. The context size should be 768. So let's try that. I want to see if it loads 768 context, and then we'll go from there. In the meantime, it's still downloading, guys. It's still downloading. It's still downloading with this 25 gigabit download connection, just to give you an idea. Lots of downloading going on. All right, so let me go over here. Let's try this guy right here. Let's try Docker YAML. Oh no, I did it again. Let's do set paste. Okay, and then what I'm gonna do here is let's do, instead of Qwen, let's call it Qwen coder GC. Okay, so that's gonna be the name. So then I think the rest is fine. So yeah, I think the rest is basically good to go. So all we have to do is wait for the downloads to finish, and we should have this Qwen coder model up and running as well. So yeah. All right, let me check for more questions. I want to check if there was any questions on X as well, because there might be a question came in there. Oh yeah, but I don't even see him now. Oh my god, that's so lame. It's so lame. Did the second stream stop? Did the stream stop again? Oh, it did. I knew it. I knew it. How dumb is this? How freaking dumb. How dumb is this? Oh no, it's still live. It's still live. All right. How long has this one been going? I can't tell, but if it might end right now because it's been like an hour. So since the last time that it crashed, I don't know why X crashes. I mean, guys, I built better streaming backends than these billion-dollar companies. I mean, I'm a little bit annoyed. I'm a little bit annoyed. I'm dealing with their incompetence in terms of streaming. So, all right, let's go back over here. So I'll check Discord one more time. No, we're just people seem to be enjoying it on the Discord. We're getting nice comments. All right, so come on. I don't remember how many. I mean, it should be getting pretty close to being done, but let's see. So, guys, this is what happens all day. Dimitri's just downloading models. I'm just sitting here downloading models. You know, I might have Steam installed on this machine because I'm waiting for models to download half the time. So, just, you know, that's the life of somebody trying to do stuff with AI. I mean, you're just constantly downloading models. So this guy finished. I'll just switch over here just in case. Let's do Docker compose up. So let's try it. It's gonna download the llama CPP container. So it's gonna pull them, but it should be fast because we have really fast. Oh, actually, it's gonna be slow because GitHub has a terrible CDN. I don't know what kind of CDN they use, but it's actually gonna take a little bit. I mean, it's slow, guys. This is GitHub's fault. So for whatever reason, this 1.361 gigabyte file is actually gonna take a little while to download, and that has to do with whatever CDN GitHub uses. This is running in a data center with a 20. I mean, it was this machine was just downloading at 25 gigabits per second, no sweat, and then now it has to download from GitHub, and it's taking like it's taking more than 1 second to download this 1 gigabyte file, which should not be the case, but that's just the CDN. That this is the kind of stuff that you learn if you download a lot of models. I'm trying to see what else, if there's anything else. There's any DMs or any other questions that I'm missing, but looks, guys, the action is in the general chat on the Discord is what I'll tell you. That seems to be where it's at. So just be aware that that's where the action is. That's where you want to be. All right, but I think otherwise we should be good. Yeah, I mean, this is so annoying. I mean, I can't believe it. Why do I have a 25 gigabit internet connection, but GitHub downloads Docker images from GHCR IO at the speed of smell? At the speed of smell, guys, there's the speed of light, the speed of sound, and then the speed of smell. So it's downloading at the speed of smell right now. Oh my god. It's almost done, though. So I mean, the fun part's gonna be, it's actually gonna take a couple minutes to load this guy up. So we're gonna let it run for a little bit. But I mean, unfortunately, I hate to break it to you, it takes a little bit of time to load up them GPUs. Wait, let's see. And then let's do. On. It's so insane. I mean, this is guys, this is like one of the constraints that we have to deal with, is that GitHub is so slow. I mean, if you have if you guys have to host production code, I would not use it. Like, I would consider not using GitHub container repository. I mean, it's this slow. Like, this machine has infinite internet speed, but this is how slow it is to download these files right now. The only thing that I'm slightly worried about is here. Wait, let me go full screen real quick. I am, for whatever reason. Let's see. I'll just in case I need it. Following. Oh no, it's going. Yeah, finally. Oh my god, I don't know why. What was going on there? It was yeah. Sorry, I know what's up. You're right. I'll show you. All right, I gotta hide one thing. Back in business over here. All right, we're back. So let's do Docker compose up. Here we go. It's gonna boot now because it downloaded the image and stuff like that. So let's see how we do. It's doing a health check. Is the health check in the, actually, let's see. Is it doing a health check in the Docker compose? I don't think it is. Okay, because that's a thing that you can do in Docker Compose. So I learned that from Claude. I mean, I would have never known myself, but it's a thing. All right, I'm just making sure we're still in business here, but it's gonna take a little bit of load, guys. We're doing is we're loading, we're loading in a RAM right now. So let's actually do. Oh, did it do a different one or what? See. Okay, load tensors. This might take a while. So what am I gonna do? So let me do this really quickly, just because. Let me. All right. So basically, let's do this. So we'll go full baller mode really quickly on this. So let's go over here. No, let's go forward. All right, I'm gonna do. Oh man, that was the wrong combination. Let's go here. Where are we? Here's the Docker. Let's do split. Okay, and then let's do space, and then yeah, boom. And then we can run NVIDIA SMI over here. Oh, there we go. It's already loaded. All right, so I think it might actually be done. Okay, so it did load all the layers. So this model is taking up, you can see right here, it's significantly smaller, so it is taking up less of the GPU. So it is behaving, or whatever you want to call it. So I still think, I can't tell if it's I don't think it started the server yet, but it did load everything in a memory, or at least allocated the memory that we need. So let's run NVIDIA SMI one more time. See how it's doing. So good. So this machine, by the way, the SSH connection, this is also so slow because I'm not gonna say where the machine is, but it's on the other side of the world. So unfortunately, I mean, we are running this on across the entire Earth. So there is like a significant latency to this machine from how I set up this stupid tunnel to, because I thought it might help X from losing the stream, but it didn't help, unfortunately. So let's do what I'm gonna do next is let's actually get this prepared let's see if we can actually curl this guy. So let's go back for that. Let's go back into here. Give me a curl to list the models on the new instance. So let's do that. It's just gonna give me a curl. I'm lazy and I have a LLM. So come on, Claude, give me the curls. Give me the curls. Okay, so it's gonna be, in my case, it's gonna be Qwen Coder, not Qwen, but good enough. Thank you, Claude. That will be all. So I'm gonna do so let's do it maybe, so yeah, let's do a new, all right, perfect. So boom, boom. So this one's not gonna work, but Qwen Coder should work. Oh crap, with an R. Let's see if it works. I don't think it's up yet. Yeah, it's not finished booting. I think it's still loading the models is the problem. It's not finished booting. We can also do the health check, I think. So let's do health. Your health. I can't remember. It's one of these. So yeah, none of them are loading. It's not finished loading. There we go. Context forcing unified KV. Blah 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 blah. Casual attention frequency. So it's still, guys, this is how it works. This is how it works. It takes forever to boot this crap. It takes forever. I mean, if you want to see, like, this is the real deal. This is what it looks like. Oh no, we might have, what did it not like? Oh, did it run out of memory? It might have run out of memory because we ran out of looks like we were with the BF16, we ran out of memory with a KV cache, so now it's trying to reboot it, so which isn't good. All right, so we'll have to I mean, we can try it. Anyway, I mean, I almost feel like getting leaving it there. It is like, let me summarize. So what ended up happening, so we did, I noticed, which was kind of dumb, which was fine for the website and stuff like that, but we had so we set the, for Kimi, we set the context size to be 16K, which is really low. I missed that setting in the Docker Compose. So basically, I mean, that's not super useful. So here with Qwen Coder, we loaded a model which was so the model that we loaded was basically BF16. So it was the fully like non-quantized model, and it was taking up like 80%. So then I told it to use a 768K context size, which means that it needs to set up a cache in the VRAM as well. And we ran out of memory. So right now it's rebooting, but guess what's gonna happen? I mean, it's gonna happen again and again and again. It's gonna run out of memory. So we can't set it to 768. So the better option, if this is the case and we can't run, because the beautiful thing about this Qwen Coder model is that it has, I mean, if I read the documentation correctly, it should have a 1 meg, whatever, token, whatever, context size, which is huge. So that's like the most useful thing. So people who thought that like Claude 4 was a gigantic improvement over Claude 3, the reason that they thought that was because the context size improved so much in the newer Claude model. So this one, what I would do on this H200 server is I would probably also go with the Q8 instead of the BF16. So I would go with the slightly compressed model, because then it will use half the RAM, and then we have more RAM on the GPU instance to allocate to a bigger context size. So I can, from my point of view, I can already tell you from a practical point of view of we want to run these models, I already see a gigantic advantage in Qwen Coder, because it is only 480 parameters and billion parameters, and but it has a context size, because the context size is super useful. So like if you ever use Claude Code, you can even see when your context fills up and when it needs to summarize, and same thing in Cursor. So what's that context size? That context size is because every time you talk to a model, an LLM for coding, you're sending the entire conversation every single time. So Cursor does some tricks where it doesn't send the entire conversation, but generally you're sending, there's like no context. You're always sending the entire conversation for the LLM to regenerate it for you. So that entire window, you're resending it every single time. So basically what ends up, what that means is you can have longer windows like that. You can have longer conversations. And it also means, from like a practical point of view, if you're doing coding, just take the freaking readmes, the entire readme of another project that you're trying to interface to, and you can just dump them in there, and it's going to have enough room to contain the entire readme in memory along with the queries that you're actually saying. So context for coding is super important. For something like an agent or something like that, it's not as important there. It's important that you give it the right context. But for coding, where you're basically pasting a bunch of documentation and stuff like that, context is king. Context is like the most important thing, like for AI coding. Once you understand how context works, you have a better idea about how all the stuff works. So my conclusion is, even though Qwen Coder BF16, we did get it up and running on a single H200 machine, it's probably better. The next thing that I'm going to do as soon as we go off the screen is I'm going to go and download the Q8 model, and that'll be the model that I get up and running and share with you guys. So the Q8 is going to fit into memory better. It's going to leave enough room for us to run like a KV cache where you can actually do stuff. With Kimi, we were forced to run the Q8 to fit on a single machine, and there wasn't much memory left. So from a practical point of view, on a single H200 machine, we're not going to be able to get I mean, so it does have I should try the 128, but I have a feeling we're not going to be able to fit 128 context size on a H200 machine with a Q8 model. And below that, you're going to see an impact. So Qwen Coder easily fits, because it's roughly, I mean, we have a lot of room left. Add Q8, we'll have even more room left than we do now. But with Kimi, I have a feeling it's going to be tough to run on a single machine. You really are going to need to run it, to run it at scale. You really are going to have to run it on 2 machines, which isn't, I mean, it's doable. It's just not not great, especially if you run a distributed GPU network. I mean, again, it's doable. We can solve it. We have GPUs that are in the same data center that connect to our network, but it's just extra work. It doesn't mean that we can run, one instance of this machine in, in North America and another instance in Asia or something like that. That is, they have to then be interconnected and have fast connectivity so that they can load balance between 16 GPUs and all that kind of stuff. So anyway, I thought this was pretty cool to show you guys the inner workings and stuff, and show you guys getting this up and running, and showing you guys how long it takes to download these models. And I mean, I just want to point out, we were just downloading with like a 25 or 50 gigabit connection. We were just downloading them, and it still took many minutes. I mean, just so you can appreciate it. So if you have a gigabit connection at home, you can expect 25 to 50 times slower. It took us like 10 minutes to download the model, so it's going to take you at least 50 minutes to download the models, probably more. You're going to need terabytes of disk space to save this. You're going to need terabytes of VRAM, which you do not have unless you have an H200 under your desk, which you probably don't have because it needs liquid cooling, all that kind of stuff. And also 700 watts, so it needs like 4 kilowatts of each server's like 4 kilowatts or something ridiculous like that. So I mean, like, no way, sorry, not happening, not at home. So yeah, so basically, I mean, hopefully you guys saw, you guys got some insight as to what it's like to build this stuff and actually try to run it and give you guys a better idea. I'm already waiting. I'm checking the chat. So somebody's saying they want to see how Qwen Coder performs, and saying that we should do Qwen and Kimi. We should do a Qwen plus Kimi vibe coding stream, which, I mean, I don't disagree. That would be a good one. I mean, maybe we do it. I'll have to see. We're going to do a stream with ElizaOS next week, which I think they're going to announce, but I mean, we should save it. I mean, let's save this one let's save it probably next week. We'll just call the ElizaOS stream the live stream, but maybe the week after we can do it with Claude Code after I play around with it some more. But I'm confident we're going to get these models up and running. Like I said, I'm a little bit more from a practical point of view of practical constraints of wanting to run it on the H200, which is, like, from a practical point of view, the biggest GPU machine that you can easily get today. So running it on an H200, if the model doesn't fit, then I mean, that's not great. Like, you should be able to fit it on one H200 machine, right? So basically, I'm more bullish on Qwen Coder just because it's a 480 billion parameter model and it has a bigger context size. So I think Kimi is more of a generic model where it can replace lots of stuff, where it's not just coding. Whereas Qwen Coder should be focused on coding. So I'm more bullish specifically for coding on Qwen Coder. I'm more bullish on Kimi for, I don't know, giving you recipes or your eggs Benedict or whatever. So anyway, but hopefully, like I said, hopefully you guys enjoyed seeing what it's like. I mean, the pain, Dimitri's gonna go get a adult beverage after this. After all this pain, my head hurts from getting all the stuff up and running. But this is the stuff we do day in and day out. We make sure all these models are pre-downloaded, that everything boots within seconds. These are all the things that we're doing and optimizing compute AI so that when you actually click in the interface, everything just boots up in a couple seconds, because otherwise you would be in this exact situation where I have to SSH onto the machine. I got to download all the models. I got to put a Docker Compose on there that does the thing that I needed to do, and then I can go from there. So other than that, we're gonna do the following. I'm gonna play around. I'm like, realistically, because I want to play around with this stuff and do some experiments. I did see, so for the Kimi, since I did see the 16K, I want to see what the biggest context window is that I can reliably get to boot on one of these instances. So what I'm gonna do is I'm probably gonna shut the machines down tonight, and I'll have a little bit of more time tomorrow in the afternoon. And I will let you know on Twitter that on X, we'll make a post. The post will say join our Discord, and on the Discord, we'll have exact instructions on how to get it up and running and how to play around with it with Claude Code and all that kind of stuff. And then if we do it that way, I'll add just to keep honest people honest, we'll probably do like a single API key as well that you'll have to add. So you'll have to set an API key so that it's not just everyone on the internet is abusing this and using it to code up their things. Because basically, I mean, we do have HTTPS, but otherwise it's sort of wide open right now. So all that stuff we'll do next week. I mean, we'll get up and running next week. So not next week, we'll get it up and running tomorrow, and then we'll probably leave these instances up over the weekend. So if you really want to try this out, and I mean, I invite you, I promise you we'll have it up and running so you guys can test that on the weekend. Why on the weekend? Because I want only people that, I mean, this is kind of the big investment to run 2 machines just for people to play around with, but we do want the feedback. So if you're serious, if you want to play around with it, we'll have it up and running this weekend so you can play around with it, and then we'll sync back and see, draw some conclusions. But I do think that in 2 weeks, we'll set it up such that we'll do a stream, and the stream will be getting these models up and running, basically. I mean, essentially running this sort of stuff so that we can we'll play around with Claude Code and actually have it try to do some productive work and see how close these models are to, I don't know, your Claude Code Opus Max whatever subscription. Which, I mean, I think they'll be closer than a lot of people think, but I think there's still, so the use case for us, for Compute AI, and for everyone interested in Compute AI stuff is, if you have a coding agent, if you want to write something that writes code 24/7 without, you know, any breaks, just sitting there coding the entire time, this is awesome that this came out, because now we can actually host it for you. We can provide, you know, enough capacity for to basically run this 24/7, and now you actually have a model that's maybe, you know, 10% off of the Frontier model, but it can run 24/7. We don't have to count your tokens or anything like that, and you can actually write an agent that's writing code 24/7, is just sitting there writing code, and we don't have to bill you API access and all that kind of stuff. So we're going to do it where if you guys stake, we're going to have at least, I mean, we're going to see how much usage it gets. I have to be honest. I'm a little bit skeptical that it's going to get nearly enough usage to, I mean, we need to see that people are actually using it. We're not going to run. I mean, this is, you know, a machine like this could do a lot more work for people doing other AI use cases on our essentially on our network. So, we would normally use a machine like this for something else. But having said that, I do see the use case where it might be interesting to have a machine like this up and running 24/7 so that you can just use it for coding, have coding agents that are running 24/7. And so then if you guys stay calm, if you guys are in the premium tier, we're going to give you access to this as part of the API. So that's the plan, at least. And then we're just going to pick whichever model is best. We're going to do some tests. I'm personally, again, I hate to break everyone the bad news from the test that we did today and the practical constraints of wanting to. So I've done consulting projects where I basically helped companies spin up Qwen coder instances. So like there's oil rigs that run some code that I wrote and all this kind of stuff. So there's use cases where you can use these sorts of models and where they make a lot of sense. I mean, obviously you're not going to have like a H200 on an oil rig, but I'm just saying like where you want to package these models for local use. So that's interesting. Like all this stuff is interesting to me. I'm like Qwen coder I use for productive work. So for me, like the underdog in all this is Kimi. I know Kimi did a good launch. Everyone's pinging Dimitri, DMing Dimitri, telling him, Netos, you gotta add Kimi. You gotta add Kimi. Kimi won. But I'm telling you, like, I'm more bullish on Qwen coder 3 just because Qwen coder 2.5 was actually super useful, and I've used it for productive work. I mean, I've done entire projects where to make sure Qwen coder is actually working, I did all the quote unquote vibe coding using Qwen coder 2.5 for the project. Okay, so I like dog fooded the project before I shipped it out to a client who plans to use it in a situation where they don't have internet and they're just offline with a model running on like a A6000 or something like that. So just FYI, so I'm a little bit more invested in Qwen coder. So Kimi's the underdog for me, but from a practical point of view, my bad news already is I think Qwen coder in terms of the memory footprint And also, I mean, Qwen Coder says that it's a coding model. It's not a generic model. Kimi is a generic model, so it needs more parameters. So I think Qwen Coder is going to be the winner in terms of I want to run it on a single machine. It could be that I'll go as far as to say I'm sure that Kimi right now is the best model to run instead of DeepSeek. Like if you want a generic model to run, but it requires you to probably run it more than one machine, which is kind of a big investment that makes it a little bit unattractive, especially because I mean you can get like so close without having to run it on two machines. That's kind of a big investment just for one model. So we'll have to see. But yeah, that's my summary. I mean, so I do think, I mean, unfortunately, I think from like a practical memory footprint test, which is the part that we got up and running today, I think Qwen Coder is a little bit more likely to be the winner, unfortunately. So fortunately, I like, again, I think I have more expectations for Qwen Coder than I do for Kimi. But we'll have to see. We'll give them both a fair test, but for sure, for at least at this moment in time, we're going to be running a single instance. So whatever quantization we do of Kimi, it has to fit onto a single instance. So we might have to go all the way down to like a Q6 on Kimi just to get it to fit into memory and leave enough room for like a big KV cache. And I would be interested in the KV cache and the context size being the maximum size for the model, which is going to be 128K. So I am skeptical. I have a feeling we're going to have to run like a Kimi Q6 even on these H200s, which I don't know. I mean, it's going to be fine, but it's not what I was hoping for. Basically, I'm a little bit underwhelmed. The memory footprint is kind of crazy. All right, so I think that's pretty much it. So questions, hit us up in the chat. Make sure you join our Discord. Make sure you're subscribed on YouTube, on X, Telegram. We have a channel. Best place to ask technical questions is Discord. If you want to hang out and talk about you know, like other AI. I mean, I feel like the Telegram's more about, you know, the token, quote unquote, and then Discord's more about cool stuff that you can build on top of Compute AI. It's like a more technical chat, so you should check out both. They're both pretty good. X is the best way if you want to reach out to us about any sort of collaboration. If you need help training your own model, anything like that, check out ping Compute AI on X. Basically you'll get handed off to me and the team, and we'll take good care of you. Other than that, if you want to try to build some stuff, hop on Discord. We'll give you a bunch of free hours and stuff like that. So just come hang out. We're super nice people. Everyone's doing super cool projects, especially the coding stuff's also pretty cool. People are doing on there, etc., etc. So I'm gonna leave it there. So I'll see you guys. We'll be doing the LizaOS dev thing, which is also Thursdays next week, and then the week after we'll actually give it a shot with Claude Code. But I was already, I mean, you can write it down, let it be said. We're the first ones who ran these models, like, or tried to get them up and running, at least downloaded them, etc. I mean, it's not that trivial. You need H200s, guys. It's not that easy to run. They're not that easy to run, these models, but we gave it a good shot and came out with some conclusions already, and we'll pick it up in 2 weeks of which of these is actually the most useful. So I'm gonna leave it there, and I'll see you guys next time. Bye.